Hello friends, Namaste. So welcome to day 25 of our exciting AI journey. Hi, I am Akshat Goyal. Today we'll be talking about transformers and BERT, how evolution of NLP models happen. So we'll be talking about transformers and how BERT is different from it. So I hope you have covered all the videos till now. So it was an exciting journey till now. I hope you could enjoy it. If you have any doubts, please do put in comments. And if you haven't watched any video, you can click the link in the description and you can watch any of the videos anytime. I hope you are enjoying it and understanding it. And if you haven't subscribed to our channel AI CodeGyan, please do subscribe it and click the like button. I hope you don't miss any single day content of the 30 AI challenge. Let's start. Hi, so today we are going to talk about transformer architecture and BERT, how evolution of NLP models took place. So now let us start with the paper thing. A paper named Attention is All You Need was published in 2017 by Vaswani et al. So it provided architecture which was to use only attention mechanism. So it was a game changer because it provided different mechanisms altogether, different from RNN or convolutional neural networks. So there was no recurrence or convolution needed. It started the transformation revolution in NLP. So let us go to the paper. About the paper, attention is all you need. So we can see there are many names as author: Ashish Vaswani, Noam Shazish, Nikki Parmar, and all. Now let us talk about introduction. Recurrent neural networks, long-term time memory, and gated recurrent neural networks, particularly have been formally established as state-of-the-art approaches sequence modeling and transduction problems, such as language modeling and machine translation. Numerous efforts have since continued to push the boundaries of recurrent language models and encoder-decoder architectures. Now, here attention mechanisms have become an integral part of compelling sequence modeling and transfer models veritas, allowing modeling of sequences without regard to the distances, input or output sequences in all, but a few cases, however, such attention mechanisms are used in connection with the recurrent network. In this work, we propose a transformer, a modular architecture, assuring recurrence and state relying entirely on an attention mechanism to draw global dependencies between input and output. The transformer allows for significantly more parallelization and can reach a new state of the art in translation quality after being trained for as little as 12 hours on 8 P100 GPUs. The goal of reducing sequential computation also forms the foundation of extended neural GPU, ByteNet, and convolution S2S, all of which use convolutional neural networks as basic building block, computational hidden implementations in parallel for all input and output positions. Now let us go to the transformer model architecture which was given in this paper. So we can see we have a input embedding, we have a position encoding. So we have multi-head attention, we have feed-forward mechanism, we have again when we talk about output embedding, we have position encoding, we have multi-head attention. So when feed-forward will process to multi-head attention and then it will use mass multi-head attention and will also take it to feed-forward, and at last it will give the output. The transformer follows this overall architecture using stacked self-attention and point-wise fully connected layers for both the encoder and decoder shown in the left and right halves. So you can go through the paper. I'll put in put the link in the description. So let us go ahead. Basically, it helps us to create the context of each word with respect to other words while we are processing the sentence, or you can say processing the we are checking the importance of each word. It will play a role which will help us. It is like a spotlight that highlights relevant information. It solves the problem of capturing long range dependencies. So when we see the example, the transform model can focus attention on important words. So here each and every word will be seen in terms of context of itself and the other words, which is called as attention mechanism. Now let us talk about attention formula. So basically we have query. So we have what we are looking for. We have key, what can I match against. We have value, what do I retrieve if there is a match, and we have scaling factor which prevents gradient issues. So this multiplication of query and key matrix, transpose of that divided by root of dk, that is scaling factor. This is passed to softmax function, which will be multiplied to the value to make sure we get the attention formula. So we'll get the output using this formula. Now let us take example of a cat sitting on mat. So the cat sat on the mat because it was comfortable. So this is sentence. So here, when processing it, attention computer scores all the words. So suppose we need to check the importance of it word, and we need to check for which this what it is used. So when we were using some other architectures, transformer architecture, it was a issue because here we are using attention mechanism, and it is basically it is going to make sure it is going to see the context of it with respect to all the words. So basically attention computer scores all the words. Higher scores for likely reference like cat and mat. Model learns it reference to mat by analyzing context. So when it analyzes context, mat word is the most probable word which it will give. So which will make sure that it is meant for mat. So the cat sat on the mat because it was comfortable. Here it is mentioned for the mat, not the cat, when we get the output score. Now let us talk about the transformer architecture, which we have seen in the paper as well. So basically it is encoder decoder structure, and we have 6 identical layers in each stack. So we have components include multi-head attention, feed-forward networks, layer normalization, and isolated connections. And now let us talk about position encoding, which is also an important one. Transformers have no sense of word order. So solution is we add position encodings to embeddings. So we have sine and cosine functions at different frequencies, which creates unique patterns for each position. Now let us talk about multi-head attention. So basically multiple attentions head working in parallel. Each head focuses on different aspect of relationships. For example, one head for subject verb agreement, another for pronouns, and another can be for. So basically when we talk about part of speech tagging, so this is an important part. So final outputs concatenated and projected. So we will get a concatenated output with the help of multi-head attention. Now let us talk about BERT, so which is also known as bidirectional encoder representation from transformers. It was released after 1 year of the paper Attention is All You Need by Google in 2018. It takes transformer decoder and adapts it for broader use. Basically, it is a encoder only architecture. It is pretrained on massive text corpus. Now let us talk about how it is different from original transformer. Basically, when we talk about original transformer, it has encoder and decoder structure. When we talk about BERT, it is only encoder structure. And whereas when we talk about context, original transformer, it was left to right processing. But when we talk about BERT, it has advantage. It is a bidirectional context. It processes context in both the directions, that too parallelly. So basically, when we talk about original transformer, it was sequence to sequence task. When we talk about BERT, it is parallel, and there are no special tokens used for original transformer. Whereas when we talk about BERT, we use special tokens like CLS and SAP, which is meant to for long range dependencies. Now, BERT follows MLM and NSP. So mask language modeling, when is used, basically it masks 15% of tokens in input. So suppose we have these sentence, the dog barked loudly at the stranger. So here when we talk about dog, so we are replacing with a mask token. So basically we need to check context from both the directions. So this is used to use context from the both directions. We are going to calculate context of dog with the help of the or either bark loudly at the stranger. So when we talk about BERT, out of this 15%, 80% replaces mask, 10% random token, and 10% with unchanged. So model must predict original tokens from the context. So this way, BERT model is fine-tuned, and to make sure to make it highly accurate and to give highly accurate context as well. So now next is next sentence prediction, NSP. So basically model predicts if sentence B follows sentence A. So basically here we are using real pairs when basically is next is true, and we have 50% random pairs when is next is false. So basically it helps BERT understand the relationship between the sentences, and it is crucial for question and answering tasks. So there is an advantage over other transformer models. So we can see the example. Suppose here is next is true, that is for real pairs. I love machine learning and neural networks are my favorite. So basically B follows sentence A, and then we talk about random pairs. I love machine learning and B is the machine weather is nice today. So basically this is an advantage while training the model. Now let us talk about real world applications. When we talk about Google search, basically BERT is used here for better query understanding with greater context awareness. When we talk about smart assistant like Siri, Alexa, so basically this is the model which is used to improve comprehension. And when we talk about content recommendation, so basically this is used for smarter analysis. When we talk about sentiment analysis, BERT is used for more accurate emotion detection. Now let us talk about the technical breakthroughs. So when we talk about the RNN, it was sequential processing, but when we talk about transform models or with the attention mechanism or BERT, so basically the parallelization was introduced, all tokens are processed at once, and it also shows the property of long range dependencies. Basically, it will process even the long range dependencies as in the limited context window which was there in RNN, CNN. And when we talk about context awareness, it has increased context awareness with the help of MLM and attention mechanism. And when we talk about scalable, basically it is highly scalable with the scales to billions of parameters. It is fine-tuned to billions of parameters. Now let us talk about transformer family tree. So basically transformer was evolved to BERT, text-to-text architecture, that is T5, and GPT architecture. And we have modern BERT architectures, Roberta. We have distill BERT. Roberta was introduced by Meta, and there is more lighter mechanism which is distill BERT. And we have more number of parameters in LBERT. We have GPT, and we have GPT, and we have GPT-4. So they are more advanced mechanisms which were introduced with the time, and that's how we could see generative AI have evolved. Now these transformers fundamentally change NLP by replacing sequential processing with parallel computation, directly modeling relationship between all words, creating rich context and representations, and enabling effective transfer learning. The transfer architecture attention makers set the stage for today's AI revolution, leading to increasingly powerful language models that can understand and generate human language with remarkable sophistication. So please do follow the video. If you have any doubts, please do put in comments. Thank you. Bye bye. Hello friends, so today we have covered about transformers and BERT, how NLP models have evolved over time. So I hope you have clearly understood it. If you have any doubts, please do put in comments, and you can also mail us at AICodeGyan@gmail.com. And please do watch all the videos. You can click the link in the description and cover all the videos in 30-day AI content challenge. And if you have forgotten to subscribe our channel, please do subscribe to our channel AI CodeGyan and do hit the like button. I hope you attend all the videos of 30-day AI content challenge, and make sure if you have any doubts, please do mail us, or you can comment below the video. Now next we'll be covering about conversational AI. So let us keep learning AI together. Thank you, bye bye. And before that, please do share these videos as much as possible so that everyone can get benefited. Bye.